All right, so we're starting with today's topic is proofs. Proofs are a pretty major part of geometry. You're going to learn a lot more about them in advanced math to get to do them. So we're just doing an introductory thing. They sort of loom large. They're sort of overwhelming for people, but the basic thing is that the basic type of proof is what's called a two-column proof. We're going to do a couple examples of that today. And honestly, are you ever going to have to prove to someone that two triangle anything about two triangles? Probably not. But if you're a lawyer, become a lawyer, or you need a lawyer, or you're in some sort of trouble, or you need to convince somebody something, the ability to construct a logical argument is a valuable thing, and that's really what we're after, is your ability to logically explain something. All right, so sometimes when we're doing these proofs with geometric shapes, we take advantage of the fact that within one large figure there might be a couple of figures, and those figures have some pieces in common, some sort of common side or an angle. So as we look at this figure, we've got a triangle ADC, you can see it, and we've got a triangle BDE. And we want to know what do they have in common, what's the common side or the common angle. And I think, if I do this correctly, I should be able to pull away that top triangle, and we can see that they have angle D in both triangles, and so typically we'll notice that since it's in both places, it's the same angle, it's going to be congruent. So that's a helpful thing as we're trying to prove something. So another case where we have geometric figures with common side or an angle, you can see that I've got a bunch of triangles, but looking at these large triangles, triangle ABD and then triangle ABC, have some common shapes to them. If we take a look, if I can pull away the right triangle, the correct triangle, both of them have that side AB in them. So I can mark that side as congruent. And it's called the reflexive property when we say that something is congruent to itself. The reflexive property, and if you think about a reflection, when you look in the mirror, you see yourself and you're congruent to yourself. And so anytime that we're saying something's equal to itself, we use the reflexive property. So let's get to a proof. We've got this one right here, and typically when we have a proof, we're given some information, some things that we might know, and what we're actually trying to prove. So in this case, we're given some information about angles, and we're going to try to prove something about the side lengths. So as we look at this, we've got angle ZWX and angle YXW, these two big angles here, that one and that one, and we've got these little angles ZXW, ZXW, and YWX, those ones right there. So to help us visualize this, we're going to just pull them apart a little ways, and then we can clearly see what's going on. Typically when we have a proof, I always like to start by marking what we know on the picture at least. So drawing the picture is a good idea. Separating the picture is a good idea. So if I mark out ZWX, that's this angle here, and YXW as congruent, that's sort of a start. And then I do ZXW congruent to YWX, that one right there. So I've got a couple of pieces marked. What I then want to do is I want to make my two-column proof, and I want to give myself plenty of room to do the writing. So I have a statement column and I have a reason column, and I hope that perhaps I can extend the page a little bit so that I have room to do my actual proof. So we're given this, and so we usually start out with a statement number one, which is what we know already. We know that ZWX is congruent to YXW, and we know that ZXW is congruent to angle YWX. And the reason how we know that to be the case is the word given. We're told that it's true right up here, so we can write given for our reason. All right. So what else do we know about these two triangles? Well, I guess ultimately what we want to do is we want to try to prove the triangle's congruent. Once we have the triangles congruent, we can say that any pieces within those two congruent triangles are congruent. So if you remember, in order to prove two triangles congruent, we need three pieces of information. At this point, we've got an angle and another angle. So if you look at your congruence rules, we probably need a side in between there someplace. So this side WX, remember back when we were talking about common sides and common angles, and you can look at the picture you have, it's in both triangles. So WX and WX are congruent to themselves. So statement number 2 is WX is congruent to WX. And the reason is reflexive. It's the same thing. That's basically geometry speak for, hey, it's the same side. Of course it's equal to itself. So now we've got an angle, a side, and an angle. And that's enough for us to be able to say that the two triangles are congruent. So I'm going to start with W. So triangle WZX is congruent to the corresponding part, triangle XYW. And the reason for that is we've got an angle, we've got a side, and we've got another angle. So we write angle, side, angle. So then now we've got the two triangles congruent. We can say things like, well, everything in congruent triangles is congruent to itself. So the last piece, and it should always be the piece that we end a proof with, is what we're trying to prove. We're trying to prove that. And so now we can say that. And the reason, I'm going to go the shorthand way, is what we refer to as CPCTC. It's a universal geometry thing. And what it means is that corresponding parts, and I can't fit corresponding, but I can fit parts of congruent triangles are congruent. So we've just crafted a little argument to logically state why we know that this piece right here, YZ, is congruent to that one. And you can't look at it and go, well, duh. Well, you could, but that wouldn't get you many points on a quiz. So we want to not do that. So let's look at another one. We've got JAB and KBA given to us, and angle 1 and 2 given to us. And we're trying to prove that this angle up here, J, is congruent to that angle, K. Going to use my little magic slidey thing, separate the two triangles out, and mark what we know. What we know is that angle 1 and angle 2 are congruent to each other. And we know that JAB is congruent to KBA. I did that in reverse order, but it's only because I could see. And we're trying to prove something about these. So same thing, two-column proof. Set up your two columns. Number 1 is what's given to us, angle JAB. And I know that probably you're going to grouse because, hey, we have to write this down. It was already written right at the top of the page. Yeah, well, that's just the way it works out. Okay, when you're proving something as a lawyer, you can't just start off with, yeah, some crime happened, let's just get to the thing. You have to set the case for what we know about everything. So we start at the beginning, we write down the given. In some cases, people are happy because they know at least they've got one step in a proof. So we've got two angles. What do you suppose we're missing? We're missing a side. Do we have a side? Do we have a common side that's in both of these triangles? Why, yes, we do. AB is congruent to AB. And the reason? Reflexive. Boom. Mark it so you can see it. Now I can see that I've got an angle, a side, and an angle in one triangle congruent to an angle, a side, and an angle in the second one. So I can use my angle, side, angle postulate to say the triangles are congruent. So we want to say triangle AJB is congruent to triangle. Let's mark out what matches A. B in this case matches that to triangle BKA. I want to make sure that the things that actually agree are in the right place as we work through this. So we'll go a little longer page. We haven't actually proved what we set out to prove, but now we can because I've got two congruent triangles. Corresponding parts of congruent triangles are congruent, and so I can say that angle J, that's poorly done, even for me, that angle J is congruent to angle K, and we're done. We always end with what we're trying to prove. Okay, if you're trying to prove that you're at your friend's house, you wouldn't stop the argument with, well, we went to the Jolly. No, you'd end it with, well, yeah, we talked to her parents, we were there. Right? So we have to end with what we're trying to prove. Okay, you're not going to win an argument by not actually getting to the end of what you're trying to say is the truth. Okay. So, last proof. see what we can get through. We may not get through all of this. I think I'm going to leave some of it for you to wrestle with and maybe wrestle with a little bit tomorrow in some form or another. This one we're going to have to do multiple steps. So we've got X as the midpoint of BD and AC is perpendicular to BD. So we can mark in here, AC is perpendicular. So what we're going to end up doing in this sort of a situation is we're going to look at this triangle here as compared to this triangle here. First of all, try to prove what we can about those. So if we do that, statement, reason. So number one, let's get the, that was awful. X is the midpoint of BD and AC is perpendicular to BD. Put the little lines over because we're talking about segments, and the reason for that is given. And then let's go with what we know. So first of all, what's it mean to be a midpoint? It means it cuts it in half. So we know that BX and XD are congruent to each other. So XD is congruent to BX. How do we know that? Well, that's what it means to be a midpoint. It cuts in two places, so we write the definition of midpoint. Okay, so we've got that part. Notice that in these green and yellow triangles, AX is in both triangles. So AX is congruent to AX. And that's our good friend reflexive. And then finally, we know that we've got some right angles. Okay, we've got angle BXA is congruent to angle DXA. And I'm going to do multiple things at one time. I'm going to use the definition of perpendicular to say that they're right angles, and then I'm going to say that right angles are congruent. Okay, if it's 90 degrees, it's 90 degrees, it's 90 degrees. So now, the picture's getting smaller and smaller as we go. I've got a side, an angle, and a side in the two triangles. So I can say those two little triangles are congruent. So triangle AXD is congruent to triangle AXB. That sounds like it would work. And our reason for that is our side angle side postulate. So then we're going to have to start looking at, because we ultimately want to get that this angle, where is it, ABC up here, this big angle up here, and that big angle down there are congruent. So we're going to start looking next at this giant, the upper triangle here, triangle ABC, and the triangle there. Okay, so long story short, what we're going to do is we're going to use corresponding parts to get that side and that side congruent. I use red so I can mark what we're doing here. We're going to use corresponding parts to prove that side, say that those sides are congruent. Corresponding parts are going to get us this piece right here. And then reflexive is going to get me that. So then I've got an angle, or I'm sorry, a side, an angle, and a side in both triangles. I've got the two big triangles congruent, so then that allows me to get the little tiny, get these angles in here congruent as well. So there's about, what, 1, 2, 3, 4 more steps on this proof, numbers 6 through 9. If you want to try those at the end of this and compare it tomorrow, or if tomorrow in class I can give you something that'll help you work that out. But we're at about the end of our time today, which just makes me sad every single time. But nonetheless, we're done with this proof thing, at least our introduction to proofs. Not meant to be mastered, just meant to show you that they're out there. You'll get to the point where you master them in pre-calculus, and that's about all I've got to say about that. Thanks for listening. Hope you learned something, and we will see you tomorrow.